Hola. Alright. This is lab number 9. Here I'm going to not do that. No table space here. Okay. I'm going to hit upload. I'm going to hit upload. Code is uploading to my Romy robot. Done compiling. Uploading. Done uploading. Awesome. Now I'm going to go ahead and unplug my Romy robot. I'm going to place it down. You know it's not going to be facing the back wall. Then I'm going to place it this way for my first one. I'm going to hit button A. My yellow light will turn on. Wait for 2 seconds, turn off. It'll begin its initial scan. It's going to look for the closest object. In this case, the closest object should be this wall. Then it's going to turn towards it. Wait for half a second. Turn 90 from it. Perfect. Then it's going to move forward based on the distance it grabs off this back wall. It's going to come 20 centimeters short, stop, rotate, come out. I'm going to get out of its way. And then it's going to scan, sees nothing, and the green light's going to turn on. That 90-degree turn, I believe counterclockwise, is hard-coded. So we're going to demonstrate what happens if it's not facing the back wall, as it said in the lab, and facing this wall. So this would probably be the worst possible starting location. Yellow light turns on, wait for 2 seconds, it does its initial scan. We didn't hit reset at all, so this demonstrates our run back with the code if we hit button A again. So it's going to look for the closest object, that's going to be this wall, turn towards it, it's going to turn 90. It's going to see there's another wall there, it's going to do another scan, it should grab this far wall. Yeah, it'll grab that far wall, turn towards it. Perfect, and it's going to turn 90, grab that back wall, come at 20 centimeters short, and then pop out and then do its final scan. And there's the green light. Alrighty, for a quick run through of what our code does, a bunch of initialized variables and stuff. This has to get cleaned up later on. But in our void loop, we wait for button A. Turns on, it resets our variables, goes ahead and turns off our green LED if this is not the first iteration of this loop. And then pauses for 2 seconds as required, and the yellow LED is just for debugging, which will get eliminated later on. So our initial while statement is while our minimum distance found by the scan is less than 40, it will run to continue staying in this loop. Once we come out to the open area and there's nothing within 40 or within 4 meters, my get distance value will automatically return this min value of 41. Because we can't differentiate between our lowest value, if something's too close or if something is way too far, my default for if get distance finds absolutely nothing is 41, so that will break us out of this in case we get to the exit. So this while loop is looking for the exit case. Sorry, this while loop is looking for our exit case if nothing's within 40. Alright, so this is actually where we get to the start of our code. So while get distance is less than 90, so it's saying if the ultrasonic sensor doesn't see anything within 90, do this code. If there is something within 90 centimeters, do this code. So within 90 centimeters would be this back wall, this top wall, or this side wall. So any of these 3 walls right here, if it sees it, it's going to run this piece of code. It's going to sweep and find the minimum distance from a robot. This should be one of the side walls. If not, that's fine also, but it should be one of the side walls. Debug stuff, it's going to rotate towards the direction of that closest thing. Within sweep, min gets assigned to our heading. Once it's there, it's going to rotate 90 from that. So our ideal case is if it's facing this top wall, it's going to face directly towards it because it's going to be the closest thing to the ultrasonic sensor. It's going to rotate 90 facing our exit. Worst case scenario, if it's facing this bottom wall, it's going to rotate 90, face this guy, and when the ultrasonic is at servo position 180, it should grab this back wall, rotate towards it, and go straight out. So it'll take a maximum 2 passes. in the worst case scenario, we expect 2 passes there. So that's going to eat up a bit of time, but not too much. But once we find our exit location, we move down, we grab a ultrasonic measurement of this back wall here. We say, go to that distance, come short by 20 centimeters. Just make sure we don't actually hit that wall. From there, rotate 90 again, and then we're going to move straight 60 centimeters. That means we should come out. Rotate 90 is counterclockwise for us, so that's going to come this way, and then come out by 60. In this case, it came here. I'm going to do a quick scan. The sweep is set at 45-degree increments. It's going to look for, again, what our minimum distance is. Because there's open area here, it's going to grab a bunch of non-measurements, or 4 meters and plus. That gets filtered out, comes back into my array as 0. And so min won't grab any of that. And then if it hits any of this stuff over here, that's fine too. It's going to be less than 40 in case it hits, for it to be assigned as min. And once it knows for sure that that 40 centimeter area is clear, it's going to go ahead and turn that green LED on and be ready for another run.